We have a calculating quantities question here. All calculating quantities questions have three stages. First stage is moles, second stage is stoichiometry, and third stage is moles. However, there's a couple of twists to this one. First things first, let's get the information out of the question and write it on the equation, and that'll help us figure out what to do. So what volume of air is needed to completely react with 2.8 grams of magnesium? So let's write 2.8 grams of magnesium there. The first thing to notice is that's a mass. Okay, we know it's a mass because it's got a unit after it. So for our first stage, we are going to be moles equals mass over atomic mass. That's our moles equation for masses. Now we're to assume air is 20% oxygen, so it's the oxygen in the air that's reacting with the magnesium. Now that's a twist, but we'll come to that later. Okay, and the question says, well, what volume of air? What volume? So our question mark is going to go over the oxygen. We cross out the magnesium oxide. So moles equals mass over atomic mass. We need to work out the number of moles of magnesium in this first stage. So that's going to be 2.8 divided by the atomic mass of magnesium. We're given that in the question there, 24. Let's stick that in a calculator. So 2.8 divided by 24 equals 0.116 moles. So what we've got here is 0.116 moles of magnesium. Right, stoichiometry. You need to look at the big numbers in the equation. We've got 2 mg reacting with O2. Now we're not interested in the magnesium oxide because our question mark is on the O2. And we've just worked out here we've got 0.116 moles of magnesium. Now there's no number before the O2, so there's no number 1 there, a big number 1. Now we've got the moles of magnesium and we want to know the moles of oxygen, so we're going from 2 to that 1. The question, how do we go from 2 to 1? What do we have to do mathematically to 2 to make it to 1? Answer, divide by 2. It's a halving relationship. So whatever we did to that 2, we need to do to the 116 here. So we need to divide by 2. So 0.116 divided by 2 equals 0.0583. So we've now found we need 0.0583 moles of oxygen. Okay, step 3, moles. Now this question asks what volume. So we need a moles equation now with volume in it. The moles equation with volume for gases is moles equals volume divided by the volume that 1 mole of any gas occupies. And you're always given this in the question. This is a constant. In this case it's 24 at room temperature and pressure. At different temperatures and pressures that number could be different, but the number at Excel always seems to use is 24. Okay, so moles equals volume divided by 24. Right, so we need to rearrange this to make volume the subject. So volume equals moles times 24. Moles is here, 0.583, 0.583 times 24. Oh, I've missed a 0 after. Let's just do that again. 0.0583. Easy to make mistakes. Times 24. And that'll tell us the volume of oxygen that's needed. Answer 1.4 decimeter cubed equals 1.4 decimeter cubed. And that's where lots of people think that's the answer. But remember I said there's some twists in this question. What volume of air, not oxygen, what volume of air? And air is 20% oxygen. Okay, so if we look at that, then 100% divided by 20 equals 5. So we need 5, a multiple of 5 of this. Now where some people go wrong is they divide by 5 to make that less, and that's obviously wrong because air is 20% oxygen. So we're going to need more air, okay, to get the amount of oxygen we need. So we need to take our 1.4 and multiply it by 5 equals 7 decimeter cubed. So our final answer is 7 decimeter cubed because we're going to need 5 times as much air than we calculated for oxygen, because air is only 20% oxygen. Air is only 1/5 oxygen, so we need 5 times as much. All these questions on elshamhighchemistry.com.